Hello, this is the fourth matrix video for OCR Pure Core AS Further Maths, and it considers the use of zero and identity matrices. In the previous two sessions, we looked at matrix multiplication and the properties commutative, associative and distributive over addition. We found that matrix operations are a bit different to operating with normal numbers and algebraic expressions. If we consider the result of this multiplication, then what we will see is that as we move along each row down the first column, only the top number in effect will get picked up because you have 2 times 1, and then all the other entries will be 0. As we move along the second column, we'll find it's only the middle number that gets picked up. And again, with the first row times the third column, it is only that third number in the row that gets picked up. That's going to be the same for each row. So we'll have, if you like, the top, the first number of the row, the second, the third. First, second and third. You may wish to pause the video here to check that this is actually the case for yourselves. But what you will find is that if you multiply any matrix A by this matrix here, you will always end up with the same matrix that you started with. If you look at the second example, you can see that it doesn't matter whatever that matrix is, you are always going to have the cell times 0 plus the cell times 0. And again, for each of those cells, you will end up with nothing but zeros in those cells. What do you think would happen if we multiplied these in a different order? So, for example, we multiplied the second matrix here by A. Try it for yourselves, but you'll find we get exactly the same result. Similarly, for this, if you like, let's call it the zero matrix times any B, you would still end up with the zero matrix. Square matrices, where the diagonals are ones and the other cells are all zeros. So there you can see on the diagonal, or again for a 3 by 3 on a diagonal. These square matrices are always called the identity matrix. So this is a 2 by 2 identity matrix and this is a 3 by 3 one. Any matrix multiplied by the identity matrix is unchanged. Right. Obviously after that, if you wanted to, you could have a think about what a 4 by 4 or a 5 by 5 identity matrix would look like. So given that any matrix multiplied by the identity matrix is unchanged, in effect the identity matrix acts like a 1 in normal arithmetic. So where you might say 8 times 1 is still 8, or 1 times 8 is 8, the identity matrix acts like a 1 for matrix multiplication. You will note that whilst normally AB is not equal to BA, in other words matrix multiplication is not commutative, if one of the matrices is the identity matrix, then AI does equal IA. Where all the cells in a matrix are 0, then we would call this the zero matrix. Some people also call it the null matrix. Any matrix multiplied by a zero matrix gives the result of the zero matrix. In this sense, the zero matrix acts like a 0 in normal arithmetic within matrix multiplication. You may also like to try adding it to or subtracting it from any matrix of a conformable size. You will find that there is no difference to the original matrix, again such as 6 plus 0 equals 6 in normal arithmetic. This was the last session in Matrices 1.